Hello. This is a review session for black box testing. This should be review session 5. Now, up until this point, these review sessions and the course as a whole have been about C++ programming, be it learning conditional blocks, loops, if else, functions, variables, structs, separating your code into modules where we started looking at design. But up until this point, the focus has been on the code, the program itself. Now, at this point in the semester, we start considering testing. And the first type of testing we consider is black box testing. Now, the basic premise of black box testing is in its name, black box. Now, what does that mean? Well, with a black box, the basic premise, and if you come from a Java background, you look at classes as black boxes. And what that means is, I have a program. I know that this program adds two numbers together. I know that I have to give this program two numbers. I know that the program will give me the sum as a result, as output. I know what I have to give the program as input, and I know what I will get as output, formatting, that sort of thing. And that's a trivial example, I'll admit. Everybody knows how to add two numbers together. Consider the first assignment, assignment 1. In assignment 1, I believe that was the throwing pies function, the control flow assignment, where you would prompt the user for an accuracy. The accuracy to which they were to the accuracy to which they desired to compute pi. If that accuracy was outside the legal range, I believe smaller than 0.01, if I recall correctly, you were to replace it. Now it's a little bit more complicated. You know what you have to give you know what the program takes as input. You have your defined legal input range. And you want to confirm that, hey, this program does in fact follow the specifications. And that's the focus of tonight. Now, we're not going to be discussing a former assignment, and we're not going to be discussing our running room updating example, the flooring example. We are going to be discussing a game of Hangman. Excuse me, did I say Hangman? No, that's the modules assignment. A game of tic-tac-toe. Now, I imagine everybody's in here has played tic-tac-toe. You have a 3x3 game board, and the premise is to connect either 3 X's if you're in player 1, or 3 O's if you're player 2 in a row. There are 3 possible outcomes for a game of tic-tac-toe. Player 1, represented by the X symbols, wins. Player 2, represented by the O characters, wins. And the game ends in a draw. Those are the 3 possible outcomes for a game of tic-tac-toe. Now, if you're playing this on paper, you draw the 3x3 grid, and you play to completion fine. It's very straightforward. You just need a pencil and some paper. Now, because this is a computer and we don't discuss GUIs or anything like that in this class, we have to focus purely on input we can type. So the basic premise is we're going to have a game of tic-tac-toe. When I want to make a move, I need to enter the row and column number in which I want to place my marker. Then it goes to the second player who enters a row and column. And then it alternates back and forth until the end of the round, be it I win, or player 2 wins, or it's a tie. Now, once again, that brings us back to black box testing. The basic premise here is I don't know how the program works. I know what must be supplied to the program as input. I know what defines valid input. And I know what I get as a result. I know what I get as output. But I don't know what happens in the middle. That's the premise of black box testing. I know what to give the program as input. I know what I've been told is valid input. And I know what I should get as output. How that happens in the middle, I don't know. And quite frankly, I don't care. That's the basic premise of black box testing. I don't care what happens in the middle. My interest is solely on, I have a statement of problem. I have a list of requirements. Does the program fulfill those requirements? That's the premise of black box testing. How you get from A to B isn't important. Now, that's very similar to if you're a commuter and you drive from your home to ODU every morning, your instructor doesn't care about it. If your instructor evaluates attendance, he doesn't care what highway or interstate or route you took to get to ODU this one. He simply cares that you're in class. And the same premise applies here. You only care that given the input, I get the output I'm told I would get. How the program does that is not concerned in black box testing. Now later on when we discuss unit testing and white box testing, those are different forms of testing, and we'll merge those together towards the end of the class. But right now our focus is on black box testing. Now I discussed the game of tic-tac-toe, which you've all played, but to test that, we need to formalize the rules for this program. Now, before I begin discussing the rules for this version of tic-tac-toe, I do want to make a note. Up until this point, the discussion has been on source code and analyzing the code and looking at it. For this exercise, the focus is on input. Now, I have provided code that you can compile and run, so you can repeat this exercise on your own. Now, the code is beyond the scope of what we've covered this far. This code goes into ADTs. You only need to compile this code. To complete this exercise, you need only be able to compile this code. You do not need to understand how it works yet. We'll discuss that in a later review session. But the focus of this exercise is compile the code and run it. Don't worry about how it works. We'll develop it later in the class. But the focus of this review session, the focus is of black box testing, is on evaluating the correctness of the program as it relates to the specified requirements. Once again, when you're looking at this example, take the source code, compile it, run the program, and don't worry about how the code works and fits together up until that point. And we'll discuss how to develop this code later in the course. Now I do have a test folder, and we will develop those together tonight. That will contain all of our input files for the program. I have two text files, and I will admit that's fairly small right there. I have two text files. The first one is test specifications formal. That's the second document we will discuss tonight. The second one is test specifications informal. Now that second document, the one I'm about to discuss here, the informal test specifications document here, is essentially me thinking of tests and writing them down really quickly just so I can get my thoughts down on paper. And we'll see in the second document how I refine those. Now to give us a starting point, a common starting point for a game of tic-tac-toe, let's define how this program is to work. Let's define the rules for this program. Play one game of tic-tac-toe. A game consists of one or more rounds. For example, if you play tic-tac-toe with a friend, you very seldom stop after one round. You usually play 2, 3, or 4. During a round, the players will be prompted to enter the row in the range 0 to 2, the common mathematical definition for a range, starting at and including 0, ending at and including 2, and column 0 to 2, for their desired moves. If the move the player selects is valid, that is, the cell is empty, meaning a player is not trying to select a cell that already has a player move in it, the board is updated. If the move is invalid, meaning that move has already been selected this round, the user is reprompted along with an error message. And this process repeats until the user enters a valid move. Now, it's very important we understand what I mean by valid move. A valid move must be a row number between 0 and 2, inclusive, including both of those, and a column number, 0 and 2, including both of those. If I enter 7 and 8, that's illegal input. I can't test it because it's not defined how I should handle that. But when I say valid and invalid, I am focusing specifically on valid. Anything in this range is a move. And valid is any such move that has not already been played this round, meaning if I select the center of the tic-tac-toe game board, it's valid if that's empty, and invalid if player 1 or player 2 has already selected that move. And this process repeats until the player enters a valid move. Once again, a row 87 and a column 42 would be illegal input. Not invalid, but illegal. Now, each round of a game of tic-tac-toe continues until either the board is full, meaning the round ends in a draw, or a player wins. The standard rules of tic-tac-toe apply. A player must connect 3 cells in a row, be it horizontally, vertically, or diagonally. At the end of a round, meaning once a player has won or the round ends in a draw, a prompt is displayed. The user is prompted to enter either a lowercase or uppercase y. That input is considered, hey, I want to play another round. Anything other than a lowercase or uppercase y, anything other than these two characters is considered a no. Anything other than y indicates that the players would not like to play another round of tic-tac-toe. Now, based on this description, we can develop a few tests. What I'd like to do before we discuss those is run the program very quickly. And now, once again, this exercise is about testing. Excuse me, I didn't mean to open that. This exercise is all about evaluating whether or not a compiled program conforms to the requirements set forth. And in this case, we're looking at black box testing. And later in the course, once again, we'll discuss unit testing and white box testing. Now, a game of tic-tac-toe. And as you can tell, it's very inelegant. There aren't any headings. It's very basic. It's a quick and dirty program for this example. And we'll see a more refined version later in the course. Now, this is the first prompt, which means player 1 is prompted. And like any good tic-tac-toe player, player 1 is going to select the center cell, the very center of the game board. So row 1, column 1. And the game board is updated because that's valid. Now let's say player 2 says, well, I really wanted the second row. 1, 1. Let us try that again. And as we can tell, I keep getting reprompted because player 2 can't select the center cell because player 1 selected it already. So let's say 0, 0 for player 2. Now let's say it's player 1's turn again. Player 1's going to be tricky. So let's say row 2, column 0. Now let's say, and now let's say player 1 makes a mistake, which means now player 2 can win. And that's the basic game of tic-tac-toe. Now, when I think about this and I look at the requirements, there are a few things I want to test. I want to test a few functional things. I want to test that when player 1 wins, the game reflects that. I want to test when player 2 wins, the game reflects that. I want to evaluate that this yes/no prompt works. I want to evaluate that when I enter anything other than Y, the program exits, that the game's considered over. I want to evaluate that the game halts once a player has won. Once player 1 has won, once player 2 has won, or once a draw has been encountered. I want to validate that, hey, the round ends if that is in fact the case. And we can think of a few other ones as we go along. But let's look at what I have written down here. Now, once again, this first document I'm discussing right now is an informal test specifications document. This is not something I would submit. This is something for me to get all my thoughts down on paper. So this is, once again, an informal listing of possible test cases. Let me fix that S there. This is an informal listing of possible test cases. We will discuss how to refine each of these into input, and we will prune illegal and invalid test cases during that process. So, the first one is the obvious case. The players complete one round. Meaning, the two players can play to the end of the round regardless of the result. And two players play more than one round. Maybe two, maybe three, but I want to test that, hey, that prompt works. That yes/no prompt works. The players can play more than one round. I want to evaluate if player 1 wins a game, if that's detected appropriately. If player 2 wins, appropriately. If a round ends in a draw, fine. If the overall game ends in a draw, if the players end a game with a draw, then I have another test here. A player enters the number of a non-existent row. For example, the player says, hey, I'd like to place a move in row 42. Now, if we go back up to the assignment prompt, players will be prompted to enter a row in the range 0 to 2. The only legal input is 0 to 2, meaning If the user enters -3 or the word, let's say tic-tac-toe, that's illegal input, and my program can handle that however I choose. Now, that's only true in this case because I said the input must be 0 or 2. I did not specify, hey, anything outside these ranges, output an error message. I said, accept values in the range 0 to 2. I can only test such values. Anything else will be considered illegal input. Now, once again, because in the requirements, restricted the players to the range 0 to 2 and define that as legal input, I cannot legally test it. This is an illegal test, and the same logic for a column. Back to our next legal test. Player 1 selects a previously selected cell, and we demonstrated that a moment ago. Player 2 selects a previously selected cell, row, and column. Same test, but except instead of player 1 doing it, player 2 does it. Do I need to test those separately? Maybe. Could I argue that I only need to test it for one of the players? Yes. Could I consider them duplicate tests? Yes. But depending on your scenario, you could argue the merits of having both, and I will leave both in here. I want to test the case where either player wins with a horizontal move, meaning 3 in a row within a row. I want to test the case where a player wins with a vertical move, top left to bottom right, or top right to bottom left. It doesn't matter. I just want to test that it works with a diagonal move. And then I want to test that a player can win with a vertical move, meaning 3 in a row within a column, top to bottom. And then I have some other cases. I want to test to see what happens when my player enters a move that fills in a top left corner of the game board. The same for the top right, bottom left, and bottom right. I could consider those boundary cases if I choose. Boundary values, excuse me. Then, line 51. The player wins with all cells, meaning 3 in a row in the top row of the game board, 3 in a row in the bottom row of the game board, and 3 in a row in the left column, 3 in a row in the right column, regardless of the player that's done it. And these are some initial tests that I considered here. And once again, this is essentially scratch work. Now let's look at that formalized a little bit. Once again, all these tests are based on these rules here. If I start saying, test what happens when a player enters the sentence, ha ha ha, I am going to break your program, that's illegal input. Simply because I said, users will be prompted for values in this range. These are the only values I can legally input. Anything else can be handled however I choose, because the specifications did not indicate how. And now this is the formal test document I've opened now. And as you can see, I've copied and pasted the description. But now is where we get more formal. Now you'll see next to each test, I have test xxx.in. Now the 3 x's are placeholders for a number. And the .in's an arbitrary file extension. Once again, on Linux, file extensions are arbitrary. File extensions exist on Linux for our benefit. Now, what we're going to do is we're going to go through each of these tests, and we're going to write the input files for them together very quickly. Now, my first 2 tests I've classified as representative input. 2 players complete 1 round, and 2 players complete more than 1 round. Now, why have I classified that as representative input? Well, my reasoning is this. When this program's run, a number of people are going to play 1 round against a friend and exit. The other case is, just quite as frequently, people are going to play 2, 3, maybe 4, and multiple rounds of a game of tic-tac-toe. And these 2 cases are representative of how the program will be used, representative of all general input. Now, beyond that, if a player wins, that's outside the scope of this test. And it's possible I will see some overlap later. Now, if I jump down, I look at my functional test. Player 1 wins a round. Player 2 wins a round. A round ends in a draw. A game ends on a draw. Players play exactly one round. Players play multiple rounds. All the same tests we had in the previous case. And I'll go through each of these as we write tests. And then I have a second section down here, illegal tests. Now, I've included this section to make the following note. Anything listed in this section is illegal and are not generally included in test specifications documents. They are included here only as part of this exercise. Do not include illegal tests in your project test specifications document or any test specifications document as a whole. And these are the two non-existent row and column tests from the earlier informal test requirements. It's perfectly fine to write down a bunch of tests and then cross some out as you're formalizing them. But what is important is you recognize tests that are illegal. Very important. Now, let's go back up to the exercises at hand. Now, I could very easily go through all of these and read them off. What I want to do is I want to start at the top, and I want to craft some input. I want to start with the first test. 2 players complete 1 round. So let's run this program and look at what we would input. 2 players complete 1 round. So let's go 0, 0, 1, 1, 0, 1, 1, 0, and then 0, 2. Now, I will admit that is a fairly straightforward way to lose, and that was the point, to get this through here. Now, what I need to do is I need to go through and I need to say, what did I enter as input? I can say, well, 0, 0, 1, 1. Go ahead and do this. There we go. Let's put a window there. And a window there. There we go. Now what I'm going to do is I'm going to create these text files, these input files at the command line. Now, there are a few text editors we can use. My personal favorite is Nano. Now, Nano is a very quick and easy text editor, excuse me. What I mean by that is it's very good for quick and dirty edits. You press Control-O to save and Control-X to exit. But it's nowhere near as feature-rich as Vim or Emacs. But Nano is good for quick and dirty text files like this. Now, player 1 first entered row 0, column 0. Player 2 entered row 1, column 1. Then row 0, column 1. Then row 1, column 0. Then 0, 2, and then N to exit. Now, I'm entering these numbers together for my benefit. If I wanted to mirror the program, I could put them each on one line. The part here is being able to parse this file myself. So player 1 enters row 0, column 0. Player 2 enters row 1, column 1. Player 2 enters row 0, column 1. Player 1 enters row 1, column 0. Player 1 enters row 0, column 2. And then the players say, no, I would not like to continue. And that's my first test file. This is the input for my first test. The users play 1 round of tic-tac-toe. And I press Control-O to save and Control-X to exit. Now, as you can imagine, if I wanted to run this test 10 times, it would be very tedious to do it all by hand. What I'm going to do is going to say, I want to play a game of tic-tac-toe. Use input redirection, a topic you've discussed in CS252. If you're not to that point in CS252, you aren't behind and you do need to catch up. I'm going to go up 1 directory into that test directory, the directory I am currently in this window here. There we go. and I want to run test0 through this program. My executable name, input redirection, go up a directory, go to my test directory, test0.in. Then as we can see, it dumps that input to the program as if I had typed it. Now, because there are no line feeds like that, you do have things like that, but that's not a concern. And we'll look at that later on. The point is now I can automate passing input into my program. I can do input redirection. And if I really want to, I could also do output redirection at the same time. Dump this as input, dump the output to test0.out. And now I have a record of my test. And later on in the course, I'll discuss a quick shell script I wrote to automate this for sake of example. Now, I'm not too concerned with that output file, so I'll remove it like so. But test0 handles that first case. Test0 has 2 players, finish a round. Now, I have forgotten, so let's see who won that first round. Here we go. Now, if I'm looking at this correctly, player 1 won the game, which means I'm testing that first test. Player 1 has 3 in a row in the top row. So 2 players complete 1 round. That's the test I just entered. That one. I can also have a duplicate here. Player 1 wins 1 round. You can have one test that fulfills multiple tests like this. Now, your goal shouldn't be to get all of this in one test. You should be able to separate it out. But sometimes that overlap is just too convenient. Sometimes that overlap is inevitable. So test0 fulfills the original intended test. It fulfills the test where player 1 wins 1 round. It handles the case where the players play exactly 1 round. It handles the case where a player wins with a horizontal move. It handles the case where a player wins with cells in the top row. And it handles the top left, a move in the top left corner, and a move in the top right corner. Now, a thing I want to emphasize, I didn't write this test with the intention, I didn't write this input file with the intention of evaluating multiple tests simultaneously. I wrote this test file, this input file test0.in, with the intention of testing my program for this case. After I wrote the input file and looked at what I did, I said, why not go through and double check, see if this test is actually evaluating something else as well. Now, 1, 2, 3, 4, 5, 6, 7 tests. One input file handles 7 tests. I'm not too thrilled about that. In my opinion, that's a fairly large number of tests for one input file, but I lucked out there. Now, it's possible to have multiple input files overlap, meaning later on I might have another test that tests the same thing, and that's fine. It's perfectly acceptable to have one input file that fulfills multiple tests and multiple input files that overlap and fulfill some of the same tests. What is not acceptable is crafting one input file to handle all of your tests. Meaning, I want to clarify that a little bit. If you write a test, an input file for one test, and it overlaps a few other ones, that's fine. But don't sit there and try to write one input file to handle everything. Your goal is to identify flaws in a program based on the test you've written. And if you have one input file that tests everything, it's impossible to identify those flaws. I mean, if you only have one test input and it fails, you have to figure out which test you failed, as opposed to carefully crafting it and having separate tests for everything. And there is a middle ground we reach, and we see that here. Sometimes that overlap's inevitable. But don't seek that overlap. If you write an input and you happen to find overlap, good. But don't sit there and spend half an hour trying to make one large input file that tests everything. Separate your tests. That is the takeaway from this. Separate your tests. Now, 2 players complete more than 1 round. Now, how do I handle that? Well, 2 players complete more than 1 round. Now, all I'm going to do is copy that. In real life, would 2 players play the same round of tic-tac-toe 2 times in a row? No. But I only need to test that the program handles this appropriately, that if 2 players play a round of tic-tac-toe, then say, yes, I'd like to play another round, and play the same round, that's fine. My goal is to test, hey, do these 2 players have the ability to play 2 rounds as per the assignment specifications? Now, I've chosen 2 rounds here, perhaps something more along the lines of 3 is more appropriate, or 4, or 5, or 6, or 7, or 8. Now, note, all I've done is copied and pasted that round multiple times, saying, yes, I'd like to continue. Now, the shortcut to copy a line in Nano is Control K. Now, once you've copied all those lines, or excuse me, cut all those lines, you press Control U to paste them. That's all I've done there. I'm simply playing the same round multiple times. And I'm going to change the name to Test 1. Confirm. Now, if I go back to this other window, I should see the program run through multiple rounds. Let's use less so we can look at it. So I see the first round. I'm scrolling down. I see the prompt, would you like to play another round? Yes or no. It prints the game board, good. I see the prompt, good. I see the prompt again, I see the prompt again. And then I get to the last prompt and they enter no. Good. It's very good. Now the players are able to play multiple rounds. It's the same round over and over, but I've accomplished the goal of this test. I've asked, can the players play multiple rounds? Yes, yes they can. So let's go back to our test specifications document and say, yes, I've now written that test, and let's save. Now, I'm looking at, I've accomplished that first test. I've accomplished the second representative test. I got lucky, and player 1 wins a round was tested through means of an earlier test. Now let's test player 2 winning a round. Now, I don't want to use the same set of input multiple times because at the end of the day that doesn't test anything. Let's let player 2 win this time. Now I'm going to take a different approach this time. When we wrote the first 2 input files, we ran the program and then duplicated it into a text file later. Meaning we ran the program, entered our inputs, and then went back and checked what they were. Let's do them at the same time. Now our next test number is test 2. Let's go ahead and open that. So on the right, I have the program I'm going to run. In the left, I have my text file open in Nano, a command line text editor on Linux. Now enter a row. This time I'm going to have player 2 win. Now, like any good tic-tac-toe player, well, that was a bad move. I meant to enter 1-1, but the point stands. Player 1 has selected row 0, column 0. Let's let player 2 pick the best move in tic-tac-toe, the center. Then, player 1, row 2, column 0. Then 1, 0 for player 2. Then 0, 1 for player 1. Then 1, 2 for player 2. And no, they don't want to play another round. So 0, 0 for player 1, 1, 1 for player 2, 2, 0, 1, 0, 0, 1, 1, 2, and now I can run that test again without having to manually type everything. and I get the same results. Now, if I look at this, I'll note that the player 2 has won with a move in the middle, but 3 in a row horizontally. Good. Player 2 has won a game. If I look at this, player 2 wins 1 round. Well, player 2 wins a round. 2. Save that. Now, round ends in a draw. I'm going to leave that as an exercise to you to test. And then game ends in a draw. At first glance, they seem like the same test. In the first one, round ends in a draw, I simply want to know, does the game detect a round ending in a draw? In the next test, I want to know what happens if the game itself ends in a draw, meaning a game ends in a draw, and the players say, no, I would not like to continue. And once again, it's possible to test those simultaneously. Now, yes, we need round ends in a draw. Game ends in a draw. I can argue that one either way. Players play exactly 1 round. If I look at this, my first representative test and this test are identical, as are the second ones. Now, I left these in here to illustrate a point. Sometimes you have a test that fits into multiple categories. Sometimes your representative test fits into functional, and that's not uncommon. But sometimes you also have tests that overlap in boundary, special, and functional as well. Now, functional, you're looking at an aspect of the program, meaning something the program should do. The functional is a misnomer. It has nothing to do with functions. Functional tests have nothing to do with functions. Functional tests have to do with functionality, something the program is supposed to do. Boundary values are edge cases, and special values are special cases. For example, dividing by 1 might be considered a boundary value case or a special case. Dividing by 0 is a special case. It's not a legal mathematical operation. I've tested a player winning with a horizontal move. That's done. Vertical I haven't done. I'm going to leave that to you as an exercise. Player wins with a diagonal move. Let's do that one together. Let's jump back up for a moment. Player 1 selects a previously selected cell. Let's see what happens. Let's craft that input. Let's make that test 3. And let's do them together this time. Test 3. So player 1 enters the row 0, 0. Then player 2 enters 0, 0. And we see that player 2 is reprompted. So let's have player 2 enter 1, 1. Now let's have player 1 enter 1, 1. Now let's have player 1 enter 0, 1. Let's have player 2 enter 1, 0. And then let's have player 1 enter 0, 2. And no, let's end the round. Now you might note that was a very basic move, but I want to focus on that one piece of functionality. I want to isolate that from the rest of my tests. Let's take a look at it. So in this case, I've tested player 1 entering a previously selected cell and player 2 selecting a previously selected cell. Now those two tests sort of go together, so I have no issue merging the two. Let's save that. Let's test that input. And good, it plays to completion, same output I got a moment ago. And that was test 3. 003. Good. Now, at this point, I've skipped 2 tests. Round ends in a draw and game ends in a draw. And once again, I'm going to leave those to you to test. Those are fairly long tests crafting that input. I'll leave that to you to test. That's an exercise. Player wins with a vertical move. It doesn't matter which player. I simply need to say, hey, does a player win with a vertical move? Well, let's see. Let's let player 1 win again. Let's make this test 4. So let's say row 1, column 1, 1, 1. Then player 2 says row 0, column 2. Then player 1 says, well, let's say 1, 2. Then let's say player 2 says 1, 0. Then let's say player 1 says 2, 2. Player 2 says 0, 0. Player 1 says 2, 1. And then finally player 2 says 2, 0. And it picks up player 2 winning. And no another round. Let's save this file. Exit. And we get the same output as a result. So let's go ahead and update our test specifications document here. A player wins with a vertical move. So at this point, I'm now going to skip a 3rd test. I'm leaving these 2 tests as an exercise to you to complete on your own. Now that's not great, it's simply an activity you need to complete. It's a lab, so to speak. This one right here, player wins with a diagonal move. You need to ask yourself, should that be separated into 2 diagonal moves? I'm going to leave that to you to test. Player makes move in the top left corner. We tested that together. Top right, we tested that together. I'm going to leave testing the bottom left and bottom right to you. Player wins with all cells of the top row. We did that together. I'm going to leave testing all cells of the bottom row to you. And then let's go ahead and add the missing line here. I'm going to leave these remaining 2 tests to you. Player wins with all cells of the left column and all cells of the right column, meaning a vertical win that's in the leftmost column, a vertical win that's in the rightmost column. And then once again, everything below this line is illegal. We don't test it, and we don't include it in the formal test specifications document. Now, if you look at this and you've gone through the black box testing assignment, you'll note that the black box testing assignment is focused on having you write the inputs for these tests, to craft the inputs. Now, note the process. While you're not being told to submit a test specifications document for the black box testing assignment, it is a good exercise to create your test specifications document and craft your inputs against that based on that test specifications document. For the test specifications document of the semester project, for the semester project, that first part due next Wednesday, you are being asked to write the test specifications document we have here, but not craft the inputs. The black box testing assignment, you're being asked to craft the inputs. That's what you submit. For the test specifications part of the semester project, you're being asked to write the test specifications document. That's where you stand now. Those are the 2 things. Assignment is creating the input. Project is creating the test specifications document. At the end of the semester with the final submission for the project, you merge those together, but that comes later. But right now, assignment creating the input, project creating the test specifications document. And once again, if you're crafting input, this is an excellent intermediary step, and I recommend you do it. But you are not being asked to submit this for the black box testing assignment. You are being asked to submit a zip file with your input files. For the project, once again, it's the test specifications document itself. Now, this is a fairly short review session and is a different focus than what we've done thus far. Once again, the focus here is on testing and testing methodology. Now, testing is important. We as programmers say, hey, I want to write code. And we like to slack on testing. I've made the mistake myself many times. Testing is a very important skill and it's a very good practice. Make sure that you force yourself to test what you're doing. It's one thing to write code. It's another thing to confirm it works. And black box testing is one testing methodology that's part of the larger testing paradigm, so to speak. It's one small part of testing. And we'll discuss 2 additional types of testing later in the course. Now with that, I will end this review session. And you can find a zip file with the source code to generate the executable I used tonight, along with the input files we crafted together, with the informal test specifications document and the formal test specifications document as well. Once again, don't worry about the code in this assignment. Compile it, run the program, generate the input files, and work through the exercise of black box testing. And we'll discuss what all this code means later.